Hello, in this tutorial I'm going to show you how to make a physics simulation in Pygame and pymunk. And specifically, we are going to be making this. We have a blank screen with two dots, and if we click our mouse button, we are spawning an apple that falls down and is physically accurate. And we can go completely crazy with this and just drop a ton of apples, and they all fall down physically accurate. At least reasonably physically accurate. And yeah, that's pretty much it. Let's jump right in. And before we get into code, let's talk about the theory of what we are doing. And the most important thing we have to talk about is the pymunk library. And the pymunk library is basically a 2D physics library. So this one can help us to calculate physics in a 2D space. And this library could stand entirely by itself. So you could just run it, not visualize anything, but have all the accurate numbers to calculate some physics simulations. But what we are going to do for this tutorial is we take what's being calculated by pymunk and then visualize all of this with pygame. And you really have to be aware that those are two different libraries, and they are fairly independent of each other. So while we calculate the physics in pymunk, we could visualize them in lots of other libraries. This could be Piglit, this could be Matplotlib, this could be Pygame Arcade. There are lots of different ways. Basically anything that can visualize data could visualize the data from pymunk. But in our case, we are using Pygame because it's a fairly straightforward library. And I do make the assumption that you already know some Pygame. It doesn't have to be much, just the absolute basics. If you don't know them, check out this video. It explains all the basics you need for this tutorial. But with all of that one done, let's talk about how to simulate stuff in pymunk. And before we get into explaining anything, we have to install Pygame and pymunk. So if you're in a Mac, open the terminal. If you're in Windows, open the PowerShell. And to install Pygame, you need pip install Pygame. To install pymunk, you need pip install pymunk. In both cases, you should be seeing a brief animation, and then you have it installed. This step should be fairly straightforward. And once that is done, you can use them like any other library in Python. So you just need to type import and import the relevant module you want to have. Let's actually talk about how pymunk works. The first thing we need for pymunk is to create what is called a space. And a space is just an area where physics is being calculated. So we are basically creating a universe with our own physical laws. And the one physical law that is relevant for us in this case is gravity. So we create a space with a gravity. And also be aware, you have to continuously update this simulation. Otherwise it's just standing still. And inside of this space, we can create physical objects. The first thing we need is a body. And a body is basically a physical body, with one major difference, that this body does not have a shape. So it can accept physics, but it cannot collide with anything. So we are basically controlling an atom right now. But to this body, we can give a shape, and this would allow it to collide with other bodies. And then when they all work together, you have a physics simulation. And that's pretty much the basics of pymunk. We're going to do all of this in code in a little bit. But again, be aware, right now, you would not be able to see anything. To actually visualize all of this, you need another library, which in my case is Pygame. But okay, with all of that one done, let's actually get into some code. So here we have the most basic setup for Pygame. It doesn't really do anything. If I run this, we are getting a screen that can't do anything. It just shows a fairly gray background. And again, check out the other tutorial I mentioned earlier to get the details on all of this. So let's start simulating physics in this. And the first thing we need is to actually import pymunk. So in our import line, I import pymunk as well. And if you want to make sure that you installed pymunk correctly, just run the code now. And if you do not get an error message, you have installed all of the modules correctly. So if pygame or pymunk have not been installed properly, then you would get an error message. And sys is being installed along with Python. If this one is giving you an error message, something else has gone horribly wrong. But alright, now we have all the things we need to get started. So the first step we need is to create our space. And this needs to be stored in a variable. I just call mine space. And to create this, we need pymunk space. And it does not need any arguments. So now we have created a physical universe that can calculate physics. But we have to give it one thing, and that's gravity. So space.gravity. And this one needs a gravity both for x and y. And I'm going to go for 0 and let's say for now 500. And what this basically means is that this is the horizontal gravity and this is the vertical gravity. And the numbers are entirely fictional. What we are looking in here is something that looks good. We don't really care how physically accurate this is. But alright, now we have a physical space and we have gravity. There's one more thing we need to do. And that is to update this simulation. And for that, we need space.step. And now we need how fast we want to update this. And in the pymunk example, it's 1 divided by 50, so 0.02, which is a fairly small number. So effectively, we have two loops in our game. We have our game loop for pygame when it updates the screen. And every time we update our screen, we are also updating our physics simulation. But you still have to be aware we have effectively two different loops that could be updated independently. Now we have a basic simulation. If I run the code now, we still can't see anything because we haven't created any objects yet. And for that, I'm going to create a new function that I'm going to call create apple. And these are the apples I'm going to drop later. And for now, this one only needs one argument, and that's the space. So this space we have created earlier. And inside of this function, we have to create two different objects. The first one is the body. And this is the atom that actually is being influenced by physics. And this is being created with pymunk.body, if you spell it correctly. And there are different bodies that you can simulate in pymunk. The easiest one is a static body. This one just doesn't move at all and it's just a static body. So this one would not be moving. However, when moving bodies come in contact with it, they would be reacting towards them. So they still have impact on the physics calculation. So when I showed you the example in the beginning, the circles at the bottom, those are static bodies because they don't move, but other physical bodies can still interact with them. The second kind of body is a dynamic body, and this is a body that can be moved. And these are the apples we have created earlier. And the third one is a kinematic body, and we are not going to create them in this tutorial. But basically what they do is that they can be controlled by the player or by some external code. Basically think of it like this. A kinematic body can move by itself and influence other objects. A dynamic body can only be influenced by outside objects, but it can still be moved. A static body just can't be moved at all. And in our case, our apples are going to be a dynamic body. And for this one, we need three different arguments. The first one is the mass of the object, the second one is the inertia, and then the third one is the actual body type, which in our case is dynamic. Mass should be the easiest one. It's basically how heavy the object is. Inertia means how difficult it is to get it to start moving. And you can calculate inertia in a more mathematical way. In our case, we're just going to use some random numbers and see what looks good. So for our mass, I just go with 1, and for inertia, I am just going to go with 100. So these are our first two arguments. Now we need to specify the body type. This will be done with the keyword argument body_type. And then we need pymunk.body.dynamic, all in uppercase letters. So now we have an atom that can be influenced by physics. And the next thing I want to do is set the position of this atom. So body.position. And this again needs a tuple, but now I'm going to set it at the middle of the screen. So x is going to be 400 and 0. So our screen is 800 by 800 pixels wide. And I'm going to set it at 400, so the middle of the horizontal space, and 0, so right at the top. So now we have an atom in one specific position, but it could not be interacting with anything because it's just an atom. It cannot collide with anything. To get it to collide with anything, we need a shape. And in our case, our shape is going to be a circle. So we are simplifying things quite a bit. And generally think of it like this. Calculating physics is really hard and math intensive. And when we later use our apple, it has a very irregular shape, which would be a nightmare to calculate. So what we do instead is we try to simplify the shape. And in our case, since the apple is fairly round, we just put a circle around the entire apple and simulate collision with this circle, which is going to make everything much simpler. But you could literally just draw a couple of points around the apple and make this much more accurate. So we need pymunk.circle. And the circle needs two arguments. The first one is the body, so this line here. And then we need the radius of our circle, which in my case, I am going to go with, let's say, 80. And this number we have to experiment a little bit with in a bit, because we have to make this as close to the apple as possible. So we basically run the simulation and see how good it fits, and then we make it smaller or larger depending on what we need. So now that we have a body and a shape, we have to add both of these to our physics simulation. and this is space dot add and body and shape. And now if we were to run this function, we would have one body in our simulation. However, again, this would not be visible, even though we have a body and a shape. So the body we are creating could collide with something, but we just wouldn't be able to see it. So we're basically using the force right now. And to make it visible, we need to return something. And what we need to return is the shape. So what we use pygame for is to visualize this shape. And wherever this shape happens to be, we are going to draw a circle in pygame. But by itself, these are two different objects. And all of this is going to happen in a different function that I'm going to call draw apples. And it just needs one argument, which I'm going to call apples. And this is going to be a list because we want to create multiple apples. And in this list, we loop through each apple. So for apple in apples. And inside of this for loop, we just want to draw a circle. And this happens with the normal pygame drawing mechanics. So pygame.draw.circle. And we need a surface to draw on, which in my case is screen. Then we need a color, which for now I'm going to just make it black. So 0, 0, and 0. And next up we need the center of this circle. And effectively what we want is to take this shape and the center of this shape and have our circle in the same position. And since each apple represents the shape, what we need is apple body dot position. So this line here will give us the center of this shape, because at the center of this shape we have the body, and from the body we can access the position. So basically what we created here in the beginning is going to be passed into our circle as well later on. And then we need one more argument, and that's the radius of the circle. And in our case this has to be 80, because when we create the circle up here, this is also 80. So I'm just going to stick with 80. And that's basically all we need for now. So in here, we created a physical body, and in here we are drawing it in pygame. So now we need to run all of these functions. And for now, I'm just going to run this create apple function once. And what I want to do is create an empty list that I'm going to call apples. And for now, it's just an empty list. And then apples.append and create apple, and it gets space. So we basically create an empty list and we create one apple and pass it into here. For now, it's just a circle, but we can insert an apple in just a little bit. So now we have a list with one circle inside of it. And this needs to be drawn now. So in our game loop, I'm gonna draw apples and I pass in the apples list. And if I run this now, we get an error because pygame was expecting an integer. So let me explain. When this one here is run, it uses floats, whereas pygame expects integers. So the x and the y position right here are floating point numbers, and we have to just convert them to integers, which we can do quite easily. So let me create some new variables. This is going to be position x. It's going to be apple.body.position.x. And this is going to be a float. So we put all of this into an argument and turn this into int. Then we copy the entire line and turn all of this into y. And now for this one, this is just going to be position x and position y. And if I run this now, we can see a ball falling downwards. It's not particularly impressive right now, but let me reduce the gravity by quite a bit. Now it should fall very slowly. And it falls down at a speed of 100. But let me increase the x to, let's say, 150. Now we can see that it's moving to the right. And we basically have our circle here that reacts to the gravity we are creating in this space. And let me return all of this to before. And this shape could react to other shapes as well. And let's actually create one. So I will create another function that I'm going to call static ball. And static ball is going to be very similar to create apple, with the one difference that we are not going to create a dynamic body this time we're going to create a static body. So static ball create space. And this time we want to create a body, and it's going to be pymunk.body. And since we are going to create a static body, we don't need a mass or an inertia, because this body is not going to move. So no matter what you pass into it, it wouldn't matter. So all we need is body underscore type is pymunk.body.static, all in uppercase letters. So this would be a body that is fixed in space. It is never going to move, no matter what you do to it. And then this body, we also want to set a position. And in my case, I'm going to set a position of 500 and 500. And the next step, we have to create a shape again. And the shape is going to be basically the same as this one here. So I can just copy the entire line. And in my case, I want to keep this a little bit smaller. So 50. And then again, space.add, body and shape. And then we also need to return the shape again. So these two functions are incredibly similar. And no matter what kind of object you create, you always create a body and you create a shape and then you add it to the space. That's basically all there is to it. And now we could actually use this function here to visualize this ball as well. However, I'm not going to do that because later on we want to change this function to create an apple at this position. So we need a new function. That is still going to be quite similar. So def draw static balls. This one needs, I think I just called this balls. And now this is before for ball in balls. We just copy basically all of this just to save some typing. And in this case, this is ball. This is ball. And the rest should be working out fine, except our radius is 50. So again, this function and this function, they are fairly similar. We basically create a shape and a body. And then from the shape that is being returned, we are drawing all of this with pygame. So when I go down, I'm going to create a list that I'm going to call balls. And into balls, we append a static ball that needs the argument space. And just to illustrate this would already work, let me run the game. And now we can see a collision. So we couldn't see the second body because it's not being drawn. But in our physics simulation, it does actually exist. So the shape of our apple circle would collide with it. But to actually draw it, I call it draw static ball and balls. So if I run this now, we can see it and it reacts properly. So cool, that's a basic start for simulation. And that is already the basics you need to create any kind of simulation. All I need to do now is to make all of this look a little bit prettier. And the first thing I need to do is to change this draw apples to actually draw apples. And what that means is I don't want to draw a circle anymore. Instead, I want to import an apple and draw this apple. And the first thing I need to do is to import an image of the apple. So I'm going to create apple surface. And this is going to be pygame.image.load. And the name of the apple in my case is apple_red.png. So now we imported the apple and it's going to be on its own surface. Now inside of the draw apples function, we have to give this position to the apple we have created on each frame. And to do that, we need a rectangle. So I'm going to create apple_rect. And this is apple surface.getRect. So we take the surface and draw a rectangle around it. And the center of that rectangle is going to be position X and position Y. So this is effectively just drawing a rectangle around the center of this point with the dimensions of the apple surface. And now I just need to put this on the screen with screen.lit. This is apple surface and apple rect. And if I run this now, we can see our apple and it's bouncing off. But you could already see that there was quite a bit of a gap, but we can fix that later. But before that, I want to first be able to click the button and then spawn an apple wherever I have clicked. And to do that, we need to update in the original createApple function this position here. And instead of a fixed position, I want this to be a generic position that I pass into the function. And then in our game loop, I want to go if event.type equals pygame.mouse button down. Only then do I want to append our apple. And the position of this apple that's being created is going to be event.pos. So basically, when I click my mouse button, I create a new apple and I pass it into the apples list. And where I create the apple is going to be the event position, so where I click the mouse. And then inside of this, it just sets the position of the body to whatever position where we clicked. So when I run this now, so now we can click the button and the apple falls down and we can get as many apples as we want. But you can see there's quite a bit of a gap. And that's because the circle we draw around the apple is too large. So let's make it quite a bit larger. Let's say 50 and see if that works. So if I run this now, it is quite a bit too large, but it does look better. Let's go for middle ground. Let's say 65. And yeah, that looks much better. So now we have our apple that falls on it. And we can do this multiple times and they all work perfectly fine. And you can experiment with this quite a bit. So for example, we could set our gravity here to something like 1000 and this is going to be 100. If I run this now, our apples move to the right. So this could both simulate wind and gravity. But for now, I just want my apples to fall down in a straight way. And that's already a pretty good start. So all that's really left to do is to update the balls so we can place those and have multiple balls. And to do that, I need to update this position here, that we don't always place it in the same position, instead we place it in a specific position. So again here, I want position, and then this one is gonna be pos. And then when we create it, that happened here. So instead of just passing space, we want to set a specific position. And in my case, this was 500 and 500. But now because we've set a position, we can just copy this entire thing and create a second one. And in my case, I set this as 250 and 600. And if I run this now, we get 2 points. And they both react to physics perfectly well. And the one difference compared to the example is that I set the color to a different value, which in my case was 217, 98, and 119. So if I run this now, we get the example from the beginning. And this works perfectly well. And yeah, that is pretty much it. Hope that was helpful and I see you around.